Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7, SEMM 4533, Subject System Design, Section 4. My name is Muhammad Afnan Hamimi bin Jaafar and my teammates members Muhammad Faiz bin Abdul Sani, Ahmad Rashamuddin bin Asmuni and Zakwan Izzuddin bin Zahari. So today we would like to present about the portable bedridden patient care device. Okay, for the introduction. Maybe someone know about the bedridden patient and someone does not know about the bedridden patient. So the bedridden patient is confined to live in a bed due to illness or infirmity, meaning that bedridden patient is stay on the bed on the bed for a long time period because of their illness. So they require a helper to help them to do their daily life activities. Other than that, they require additional care to avoid the formation of pressure ulcers due to the long period of time in the same physical posture. Meaning that when the bedridden patient stay on the bed for a long time period, it will cause the formation of pressure ulcer that can harm them. So they need a helper to always change their position to avoid this. So for our project, we'll only focus on the torso part. The torso part is also known as the trunk, which is the part of the body where between the neck between neck and the stomach. For the torso part, this does not include the hand part. Okay, for our problem statement is bedridden patients are vulnerable to various health complications, which is among them are pressure sore and muscle-related problems. Pressure sore may cause the blood toxication, which may end up with death. Problem with muscle contracture and stiffness may restrict the movement of the body part. So this complication reduce the patient quality of life. Therefore, we need to design a device with the following specification to help them to improve their quality of life. So the specification of our design need to be designed is device must be portable, and the second is the device will handle one of the complication. Third, the device will be used on the specified part of the body. So for our part of the body is torso. So lastly is the device must be able to store the activities based on the patient on the device and cloud database.
Hi, I am Muhammad Faiz bin Abdul Sani. So I will continue our group presentation with research background and product design specification PDS. Based on our research on the internet, the bedridden patient often had the chance to be having other complications such as bed sore during their bedridden periods. Basically, bed sore is ulcer that happen on the area of the skin that are under pressure from lying in bed for such a long time. So we will focus on the torso part of the patient. Next, we will continue with product benchmarking that are currently available in the market to help reduce the bed sore. So the first product is gun body relaxation, which help in reducing the muscle stiffness of the patient. The second one is adjustable bed that help in changing the posture of the patient from time to time. And the third one is inflatable mattress, which is an ergonomic mattress that provide free flow of air for the patient. Next is our research background. So we did our research based on article, newspaper and internet, and we have found that bedridden patient is among elderly, which is around the age of 58 and above. And based on the research done through online platform, we had found that bed sore complication or bed sore problem often occur among those who are bedridden for such a long time and did not move on their bed for a long period. And next is based on observation, we noticed that at least one helper is needed to help the patient to use the device for the bedridden patient. So next is from surveying on social media that we had done, the lifespan of the product should be more than 2 years to reduce the maintenance cost. Next is the PDS element. There are about 11 elements that should be considered during the design process. So the first element is the age of the bedridden patient. The majority of bedridden patient is around 58 years old and above. The second one is the income, which is RM1000 to RM2500. This is considered as their pension, their insurance, or their allowance from their children. So the next one is the weight of the bedridden patient. This is the average weight, which is 63 kilogram, and the next one is the mobility of the device. The device should be available to be used anywhere and easy to move. And next is the size of the bedridden patient. The bedridden patient size, the average size for the male patient is 160 centimeter, and the average size for female patient is 150 centimeter. And the next one is the helper. At least one helper is needed to help the bedridden patient to use the device. Next is the safety of the device. The device should have a dull and soft surface, and the device should be available to prevent from unwanted injuries. Next is the lifespan of the device. The lifespan of the device is greater than 2 years, and the price of the device is around 500 and above. Next is the ergonomics. Ergonomics is important for the bedridden patient to prevent the bed sore. So the ergonomics point here, it should according to the position of the body shape of bedridden patient. And the last point is movement. The device should be available to be level accordingly, and the movement of the mechanism should be suitable for the bedridden patient in order to prevent the bed sore. Thank you. That's all from me.
I'm Zakwan Izzuddin bin Zahari. Okay, I would like to continue with function decomposition. Okay, type of complication that we choose is bed sore because we are focusing on torso part. Okay, next is function structure. Here we divide into 3 parts, which is input, focusing on initial part before the use of the device. Next is black box parts. This is focusing on the device, the function of the device. And also last one is output part. Output is what we want to get from the device, the result of the device, the benefit of the device. Okay. For the input, we start with maybe from the bottom one is helper. Helper is to help the patient install the device. After install the device, the patient we must position the patient, and then after the patient positioning, we switch on the device. We turn on the device, and when the device is on, there are movement of the device, and after the movement, we monitor to get the data, to get the patient data. We monitor the level, we monitor the time, and how we control it. Here we can see another arrow back to the switch on, which is to control the device, the level, the time, the level of the device. Okay. And after we monitor, we uninstall the device. Uninstall the device from the patient to get these 3 output, either data, bed sore prevented, and also patient satisfied. Okay, next input is patient patient, repositioning, switch on the device, and after we switch on, there are movement of the device, monitor, and also install, and we get this out. Okay, the last input is power itself. Okay, power to switch on the device, to turn on the device, we must have the power source. After we switch on, it repeat again the movement, monitor, and data update. Okay, that's all for function structure. Okay, next I would like to continue with morphology chart. Okay, here there are 6 functions with 4 solutions for each function. Okay, the first function is install device. How the device look like. First one is shirt, bed, either bed or chair, and also maybe mattress. Okay, next function is positioning of the patient. How the patient sleep, how the patient commonly commonly position. Here we can see there are bed sleeper or common sleeper. There are common sleeper out there. Next is prone sleeper or stomach sleeper. There are also side sleeper, maybe, and lean back sleeper. Okay, next is power. Power is to power the device, to functioning the device. We use maybe electric, battery, solar, and also electric. Okay, next function is switch on the device. We are using remote to switch on the device with only one click, the device is turned on. We also control the device with this remote. Okay, next is IoT, Internet of Things. This is another level. Okay, maybe also joystick and also button controller. Okay, next function is monitor. How we monitor the data, how we monitor the level of the device, how we monitor the time of the device. We using maybe mobile or LCD, LED display, or LED indicator, also PC screen. PC screen is commonly used out there at the hospital. We can use it. Okay, the last function is device movement. How the device is moved, how the mechanism of the device. Okay, here we list. First is up and down of the device. Meaning that the device is up and down at the same time. Next is vibration. We vibrate the device with the vibration. Okay. And the last two solution here, rolling movement and punch movement. This is commonly used for the massage up there lah. Rolling and punch. Okay. Maybe that's all from me. Okay, now I would like to talk about my concept selection. Based on the morphology chart, I choose bed for the how the device look like. Okay, for the bed, for this bed is commonly used out there at the hospital. Maybe here there are some improvement only on the bed itself. Okay, first one is from the normal bed, we can adjust the bed, adjustable bed. Maybe adjust the level of the bed, the degree of the bed from 120 degree to 90 degree to back to 180 degree again. Okay. Next is surface itself. Here I'm choosing to use bubble shape or ball shape. This shape is focusing on critical point. For example, for my part, torso part, the critical point is back, is on the back of the patient, the back of the patient. Okay. Here, there maybe we can add some vibration, like massage chair. Okay. Next, how we control the level of this adjustable and also the vibration by using remote wire. Why I choose remote wire, not wireless? This become more easy to the patient itself. When wireless, maybe it's become difficult for the patient to grab it. Okay, here I attach the remote to the bed. Okay, by using power source is electric. Okay, next is monitor. How we monitor the level and also the level of vibration. Okay, by using PC desktop or PC screen. Here we can monitor the degree of the adjustable, either 120, 90 degree, or 45 degree, or 180 degree. Okay, and also the level of vibration, either low, high. Okay, next is bed mobility. I'm choosing lock roller because lock roller become more easier for the bed to move either to the right and also to the left, and also we can lock it. We can prevent it from the bed to move easily, to move randomly. Okay, the last one is add-ons. This commonly out there at the hospital. There are some mattress on the bed, on the surface of the bed. Okay, maybe as on the mattress that our group discuss next concept generation. Maybe we can combine these two between bed and mattress. Okay, that's all from me for my concept selection. Okay, thank you.
So this is the second concept from our group. So basically the second concept is like a chair that can be turned into a bed. So if we see here, this chair can be tilted into bed. So the back support of the chair can be tilted into the bed and can be moved here, down here. And the footrest of the chair also can be tilted up to be a bed for the bedridden patient. And the mechanism of the back support, here in the back support of the chair, we have massage ball that will have been the multi-directional movement of punch ball. So here we decided to put a punch ball so that whenever the bedridden patient sit here, the body of the bedridden patient can be punched or massaged. The massage ball also can be having multi-directional, so it can be horizontal and it can be vertical. So it will provide different movement for the body of the bedridden patient. So it will prevent the bed sore. Next is the bedridden patient also can alter the speed or the intensity of the massage by controlling using this button here on the armrest. So the button will control the intensity, the speed, and any other variable for the chair. So for the back support here, we use an ergonomic cushion, which is a memory foam cushion that will remember the shape of the back body of the bedridden patient. So it will give a full support for the back body and prevent the bed sore. And here we have a container for litter. So the container for litter will be used if the bedridden patient want to pee or poop. Some of the bedridden patient cannot afford to go to bathroom or toilet to pee, so they can just pee here. And this container can be changed every time. So next is the braking system. So on the wheel, we use braking system to fix the chair in one position to avoid any unwanted injuries. This chair can be activated. This braking system can be activated by controlling using this button or manually by the helper. And next is the monitor. This is monitor attached to the chair that can be used to monitor the bedridden patient condition, and also the massage speed. The condition that can be monitored is such as SpO2, the blood pressure, and more else. So the monitor also can monitor the speed of the massage ball. So that's all from the second concept. Thank you.
For the concept 3, I designed it with about the mattress device. So this mattress device will build by using the tube A and the tube B. So this tube will arrange like that and become a mattress. So it will this tube will strap on to hold the tube. Okay, this tube A and tube B will connect to the electric pump. The function of this electric pump is it will pump the tube A and B alternatively. Why? Because this device will move up and down as the pump is on. To on this electric pump, we use the IoT device such as mobile phone. So we just need to click on the switch on the phone, so this electric pump will on. For on this mobile phone device also, it will help the helper to monitor how many hours that they use this device to the bedridden patient. Also show the battery life of the electric pump. And that's
So for concept 4, I use the install device with shirt, and the power I use battery, and the switch on I use button controller, and the device movement is vibration. So this is my concept designs that I draw. So at the backs, I apply the vibration movement, and the dotted spot is focused on the critical point at the backs, and the vibration is controlled through the button controls, which is at the control switch. So the control switch is able to on or off the vibrations, and we can increase the vibrations or decrease the vibrations. So I choose to using battery, which is lithium ion battery. It is same used in laptops, because I use this battery because it is light and high voltage and density, and it's also rechargeable. As our concept is less than 6, which is we has 4 concepts, we will use scoring techniques to score our designs. So the selection criteria is the age limit, costing, weight, mobility, size, helper needed, safety, lifespan, ergonomics, movement, and creativity. So for concept 1, I will talk a little bit for the best and the worst. So age limit, we put the best, which is scoring 2, because we believe that this concept can be used for at all age. So for the costings, we put the worst because we believe that this is the high cost. And the lifespan, we believe that this concept is will last long, so we put 2, which is the best. And the ergonomic also we put 2 because we can see that at the surface at the surface of this concept, it focuses on the critical points. Next, we move on to concept 2. So for this concept, we can see that the age limit we put the best because same as concept 1, it can be used for all age. For the costing, we also put height, so it's the worst because we believe that this concept will be highly cost. And the ergonomics, we put the best because we also can see the surface is very good. And the creativity, we put -2 as the concept has nothing new in it. So next, we move on to concept 3. For this concept, it's a good design because we can see the mark, the scoring mark is a lot of 2 in it, which is the best, which is the age limit, weight, size, helper needed, and safety. So it just the creativity, this design just lack of creativity. Next, we move on to concept 4. For this concept, the weight and mobility, we put the best because the weight is very light and it can be bring to anywhere easily. So the helper needed, also we put 2, which is the best because it only use one helper need. It only need one helper to assist the patients. Then the creativity, we put 2 because this is the new thing and these products never been produced before. So this is the conclusion for the scoring marks. So we can see that the concept 3 had the height mark, which is 1.19, followed by concept 1 0.84, followed by concept 4 with 0.7, and concept 2. So this is concept 3. According to the Sustainable Development Goal, which proposed by United Nations, this device belong to the at the goal 3, which is good health and well-being. The description of the goal is to ensure a healthy life and promote well-being for all at all age. As our project man's idea is to promote healthy life to all, including the bedridden patient. So this goal is relevant to our projects. For 1010 Malaysian Science, Technology, Innovation and Economy, or MySite framework, our device is related to 10 of the socio-economic driver, which is medical and healthcare. This is because we designed the device for the bedridden patient to improve their quality life. With our device, it can prevent the bedridden patient from having a pressure ulcer that can lead them to death due to staying on the bed for a long periods. So this is suitable for our missions and our goals. And then it can help more people in the future. So that's all from us. Thank you and enjoy.